Hi viewers, welcome to today's episode of Utilary Online Maths class. In today's video, we have a question on set which involves a word problem. And as promised, that's why I brought the question because, when I taught you about the theory of set, I explained the terminologies and the rest. I said we will bring in a word problem that will be using our initiative of the set terminologies we've learned, right? So in today's question, we have a question that says, in a class containing 10 students, 6 are offering start 1201. This STA means statistic, right? And 7 are offering MTH, which is mass 1301. How many students offer the two subject? That's the question, right? So using the idea we've gotten in the previous videos, let's see what we get. So the first thing you should consider in this kind of question is what is your universal set, right? They said in a class containing 10 students, this very place is a very big keyword to use, right? Because the total student in the class is what? 10. That is our word, universal set. So the universal set, which I'll be denoting by mu, is equals 10 students, right? So the next thing is I'll be denoting the statistic. I'll be denoting it by letter S for simplicity, right? So they said 6 are offering start 1201. So I'll be using S for statistic, which they said is 6 students. I'll just denote it with 6, right? The next one is they said and 7 offer mass 1301. So I'll denote mass with letter M, and they said there are 7, right? So the question now is how many students offer the two subjects? In this kind of thing, you'll be like, okay, since I know 6 students offer statistics, 7 offer mathematics, I'll sum up the numbers. If you sum 6 plus 7 is 13, which is greater than the total number of the students in the class, which you know by yourself you are wrong, right? So that means there are some minor calculations you need to do. When I say 6 students offer statistics, it's possible that the 6 students, there are some of the students that offer this very course that still offer mathematics, right? So that means this 6 you are saying does not mean it is only statistics. It's possible that some of the students still offer mathematics and still offer statistics, right? And same thing with that of mathematics. We have mathematics to be what? 7. It's possible that the total number of students offering, the total number here is 7, does not mean it's just mathematics alone. It's possible that the 7 here still involves those that offer statistics again, right? So that means we need to do something to get the total number of students in statistics and total number of students in mathematics. How do we do that? We need to check their what? Intersection. So if I may ask, what is their intersection? Which is M, we all know is intersection S, which I told you what this very sign means, right? I said it's intersection. In case you don't understand some of the symbols I'll be using here, you can check on the video, which I'll be dropping the link in the description, because I've made the meaning of some useful symbols instead. So we have M intersection S, which means the students that offer both statistics and mathematics, right? So the total number, in the whole of the question, we don't have that number, right? So that means let's just denote it by any letter, which I'll be using X for the sake of this video. That means the intersection, I don't know what it is, right? So if I can calculate the value of X, that means I've calculated what they say I should calculate, because they said how many students offer the two. And the student that offer two, that means is intersection, right? So how do we go about that? Let's draw a Venn diagram first. Let's see what we can get. Oh, let me do something. M intersection S. When I say complement, I mean M alone, right? So for mathematics alone, we have 7, right? 7. I'll subtract the total number of students that I say offer the two. I want to get just the number of students in mathematics. So I will say 7 minus X, right? Which I will call this, I will just say math only, which means this very point belongs to just mathematics, right? So the next one is when I say M intersection S, but this time around is M that is complement. And you remember what I said about complement, right? When I say complement, it means that very set does not belong to that place. So when I say M complement intersection S, it means the student that offer just statistic alone. How do I do that? That is going to be number of statistic is 6. So 6 minus X, where X is the number of students that offer the two, right? So I'll call this very point start alone, statistic only, right? So you can see that We subtracted the total number of students that offer the two subject, which is X. We subtracted from that of mass, subtracted from that of statistics, and we have numbers like this, right? So the next move you have to make is, okay, since I have these numbers individually, let me sum them up to be equals what they say the total number of students in the class is, right? So the next move is to just say, okay, that is going to be M intersection S complement plus M complement intersection S, then plus the intersection itself, M intersection S, um, which is equals what? 10. That's what they say, right? So what is M intersection S complement based on what I've said? What I mean here is, to get the total number of students that are in the class is to sum up those that are doing statistics and some of those that are doing mathematics, right? Then some of the people that do the two, which is exactly what I did here. So for M intersection S complement, you can see I said 7 minus X, right? Sorry, let me just continue here. So 7 minus X, right? Then plus, let me put it in the bracket, plus M complement intersection S, which is where we have this, right? 6 minus X, 6 minus X, then plus M intersection S, which is X. That's plus X, and everything is equals 10, right? So let's sum up everything and see what we've got. If I expand the bracket, this is 7, sorry, this is going to be 7 minus X plus 6 minus X plus what? X is equals 10, right? So from this, you all know that X can cancel X because this is negative X plus positive X, right? So the only thing left is going to be 7 plus 6, that's 13. So 13 minus X is equals 10, right? So I need to take 13 to the other side because I need X, because that's what the equation needs, which is the total number of students that offer the two. So taking 13 to the other side, I'm going to have minus X is equals 10 minus what? 13. So minus X is equals minus 3. And I can't say I have minus X. Instead of all this, I can just divide both sides by -1 or multiply by -1 such that I'll have a positive number, because we can't have a negative human being, right? So if I say dividing both sides by -1, you can see that this will go with this with this, so that X is equals 3. So that means the total number of students that offer the two subjects is what? 3. So like I said, I wanted drawing the event diagram for this. If you like, you can just draw it based on the information we've gotten here, which is, let me just summarize it here. It's just two sets, which is statistics and mathematics. So I'll make it this. Sorry, I think I've made it so big. We should have this with this, right? So let's call this mathematics. Let's call this statistic, right? So we said their intersection. We don't know it in the first place, right? We said it was X. X. If you like, you can just substitute in, since you've calculated what you need, you can just insert the main values, right? So I'm trying to substitute the equation in a Venn diagram first, because sometimes it's more easier to use the Venn diagram to solve the equation. So we said their intersection is what? X. Now for M alone, can you see? It's 7 minus X, right? So for this region, I'll be having 7 minus X, right? For statistic alone, we said it's 6 minus X. But we said this very region is the universal set, and we said it is 10. So at the end, if the reason why I'm subtracting X is, we already discussed here. So you just sum up this, then you get what we are having here. If you like, at the end, you can now draw the Venn diagram for the answer, because you've calculated for everything, right? So for the whole answer, sometimes while solving this question, you can draw 3 Venn diagrams or 2. Draw that of the question and draw your result, right? So for the two sides, I'll make it small because right now I have the result. So I'll still call this my M. I'll call this S, right? So look at, for the intersection, we said it's X, and we said X is what? 3. So I can just substitute 3 here, right? So we said for M alone, which is mathematics, we said it's 7 minus X, right? So 7 minus X, but X is 3. So 7 minus 3 is what? 4. So this point, I'll insert 4. For statistic alone, we said it's 6 minus X, but 6 minus X means 6 minus 3 because X is 3. So 6 minus 3 is what? 3. So at the end, you can now see, the whole rectangle we are having here means the universal set, right? So 4 plus 3, 7 plus 3, 10. You can see that it has given us the universal set given in the question which says in the class containing 10 students. So that's the idea on how to solve a word problem. I also make a more tricky and so a more advanced word problem that involves 3 sets, because this very one involves just 2 sets, right? So don't miss out the next video. And if really you enjoyed the video, I hope you share the video and subscribe as well. Thanks for watching.